Hello and welcome to a Linux tutorial from filmsbychris.com, where today we're going to be playing with image files, ISO files, and QEMU, which is how I believe you say it from what I could find online. QEMU, spelt QEMU, is a processor emulator and a virtual machine all in one. If you've worked with VirtualBox, a lot of the VirtualBox technology is based on source code from QEMU. Now, both can do a lot of the same things, and normally if you're just going to be running a host operating system, people will use VirtualBox. Some of the things that QEMU is normally used for is, since it's a processor emulator, you can compile software for other processor types. So basically, if you're running on a regular x86 processor, that most desktops would run, and you want to compile a program for Linux, but on a different processor type, like let's say an ARM processor, which is what most tablets and cell phones run on, you can't compile. Well, you can cross-compile for them for other processor types. But one of the ways it's normally done, especially if you're going to be putting together a whole operating system, like on my Nokia N900, I have Debian running from an image file. Well, you would use QEMU to install a ARM version of Debian on your desktop, but within that processor emulator. So without getting too technical, that's basically what it's used for. But we're going to do a lot of fun things with it here. So let me start off and just jump right in here. I'm going to list out the files I have in this directory. Right now I have one file. It is a ISO file for the Linux distribution called Slitaz. Slitaz is a very small, it's a 30 megabyte desktop environment distribution. And I'm just using it in this tutorial just because it's so small. It uses little processor and other resources, and also it will install relatively fast since it's only 30 megabytes. So let me go ahead and show you how QEMU starts. So first off, it's not installed by default, so use your package manager to install it. It should be in the default repos for most distributions, if not all. So we're going to say QEMU. And then I'm going to tell it that I want the CD-ROM for this virtual environment to be this ISO file. So I'll tell it the ISO file that we have here. And I'm going to tell it -M for memory. So now I have 2 gigs of RAM on my desktop here. How much of that RAM do I want to give to this virtual environment? And Slitaz is pretty lightweight, so I don't really need that much. I'll go 256, which is probably more than enough for Slitaz here. So I hit Enter, and you can see it opened up a little virtual environment here. I can hit Enter to continue the boot process. Now, I've clicked inside this window. You notice that it's grabbed my keyboard and mouse, but you'll notice also at the top of the QEMU screen, it says press Control-Alt to exit grab. So if I press Control-Alt on my keyboard, you can see my mouse is now free of that virtual environment, and I can click on other windows and move away from that. Once again, I'll click back in here. Now, Slitaz normally boots in about 10 seconds on even machines with 256. For some reason, running this processor emulator, it seems to hang a little bit right here at this where it's checking the first CPU. Not sure what that's all about. It's just because we're running inside a virtual environment. So we'll just give this a moment to catch up. Okay, moving along with the booting process here. In a second, Slitaz will ask me 1 or 2 questions about my keyboard and language that I want to choose. And then it should boot into our desktop environment, which is lightweight. I think they use ICE Window Manager, if I remember correctly. And then I'll show you that basically we're running inside a virtual machine just like you would with VirtualBox. So I'll hit Enter there, and I'll choose a language, US. It's going to configure our Xorg and start up our desktop environment. Okay, so we got our desktop starting up here. Okay, everything's loaded. And as you can see, I can... As of right now, there's not too much difference between this and like using VirtualBox. We're just booting an ISO, so it's a live image. Any changes we make will be gone next time we reboot the virtual machine. So how can this be used to create an IMG file, an image file, that we can later on install to an actual hard drive, device, or do other fun things which we'll be going over in future tutorials coming up here in the near future. Well, let me close this out here, and I'll restart it. I'll cut out the boot process to save time in the video, but I'll show you the command that we need to start up QEMU to do a install to a image hard drive. So we'll shut down this computer here. Okay. Now going back to our command prompt here. In fact, I'm just going to kill that. So last time we typed QEMU-CD-ROM, the name of our image that we want to be our CD-ROM, and the amount of RAM that we want to use. Well, that's great, but let's before we do that, let's create an image file. So what we're going to use is QEMU-IMG to create an image file. We're going to say we want to create an image file, and then we need to give it a name. I'll just say slitaz.img, and we want to give it a size. And slitaz isn't that big. I'm going to say a gig, which is once again probably more than enough because it only takes, I think like 125 megabytes of space once it's uncompressed and installed. But this will give you some room to work with. We'll hit enter there, and boom, right away, if we list this out, you'll see we have a new file. We have our original ISO file and IMG file. Now if I list with -LHA, you can see that the IMG file, even though we haven't put anything in it already takes up 1 gig of space. So that's been allocated and set out for us. Now to start up QEMU with some differences than last time, what we're going to do is we're going to say -HDA for our first hard drive. And what do we want our first hard drive to be? It's going to be that slitaz IMG file, the image file. And then just like before, we're going to do CD-ROM, and we're going to use our slitaz ISO file. And then to choose the boot, I don't know what the default boot option is, whether it's a CD-ROM or hard drive in QEMU, but just to be sure we boot off the CD-ROM this time around, we're going to say -boot D for the CD-ROM, and we're going to say M, once again we'll do 256. I'll hit enter. I typed something wrong. Oh, the ISO file isn't called slitaz ISO, it's slitaz-3.0. Okay, and we'll hit enter, and we'll start this boot process. I'm going to cut out the boot process just to save time in this video. Okay, that's done booting, and we're inside the slitaz environment, once again running off the ISO image. But since we used the command back here, whoops, go out of the virtual environment here, and we loaded up this IMG file, which is an empty 1 gig IMG file, we can now partition that and install slitaz to that image file. So let me start up. I already have done tutorials in the past on slitaz and doing install, and you don't have to use slitaz. You can do this with any distro. You can even do it with other operating systems if you like. And basically just go through the install process you normally would. But quickly, I'm going to show you that the image file does show up as a hard drive. What I'm going to do is I'm going to say fdisk device HDA, because that's what we said to. Oh, have to be root. So sudo and slitaz the default, or I'm sorry, su and slitaz the default password is root. And we will fdisk device HDA, because that's what we have it set as, the first hard drive there. And if we do P, there's no partitions. We'll just hit N for new, P for primary 1. We'll just use the default options to use the entire hard drive. And then we will W to write that. Next, I'll start up slitaz installer. We're going to do an install. It's going to ask me to pick the hard drive device I want, which once again will be our device HDA, in this case the first partition, which is 1. And yeah, we'll just use ext3. That sounds good. And I'll go through the default options. I don't need a separate partition for home. My host name will be slitaz. Root password we'll leave as root. We'll create a user called Tux, and his password will be Tux. And yes, we'll continue with this install. And I will speed this up and cut to the end. And then we'll boot into that ISO image. Okay, operating system's installed. Let's go ahead and install grub to the master boot record of our image file. Should only take a second, then it'll ask us if we want to reboot, at which case I'm going to actually exit because I want to shut down, not reboot. There we go, exit, and then I'm going to click here, log out, and I will say shut down the computer. Okay, and once that is shut down, we can now boot into that IMG file, that image file. Which, by the way, does not have to end in .img. You can call it whatever you want. It's just normally they're called IMG files, so the user knows that they're image files. So basically our same command as before. We could just change this. If we do QEMU-help, we can scroll up here and find... Where is it? I guess we can grep it out. Let's use grep. And right here inside our help options, the boot option, you can see that if you put A, that would be the floppy drive, C would be the hard drive, D is the CD-ROM, and if you want to do a network boot into QEMU, you can use N. So at this point, we can run that same command as before and change this D to a C if you want to leave the ISO mounted as a CD-ROM drive, or you can just remove that altogether and just boot into the IMG file. So it all depends on whether there's going to be stuff in an ISO file that you want to use as a CD-ROM, maybe to install some stuff or just as extra files. I'm just going to QEMU-HDA, the name of our image file, and -M 256 for our amount of RAM. I'll hit enter on that. As you can see, it's not the ISO startup screen, it is the install startup screen, or the grub startup screen, I should say. We'll hit enter to continue that, and just once again to save time, I'll cut out the boot process and just go straight to when the desktop is started up. Okay, we got SLIDTAS started up in QEMU off of the IMG file we created. Username Tux, and we set the password to Tux during the install process. And then we should get our desktop environment here. Now, just like it's installed in a virtual machine or on a hard drive, we can make changes to this, this distro, this OS, and all of them will be saved to that IMG file. So, now why would you want to do this? Once again, you can work on operating systems for other architectures. QEMU supports pretty much all architectures out there, all major architectures, PowerPC, ARM, 64-bit, x86. Those are the only ones I know off the top of the head, but there's like at least 8 others, I would say, which Linux also supports all of those. So you can compile or work on Linux for different processor types within QEMU. And save an IMG file. And once you create the IMG file, you can then DD that to a hard drive, and you can also mount it and play with it using chroot, which is what we're going to be getting into in the next tutorial. So we're going to do some fun things with image files in future tutorials. This one was basically creating one using QEMU. I thank you for watching. Please visit filmsbychris.com, that's Chris with a K, and also visit us on Facebook. There should be links in the description of this video to all that information. And I just thank you for watching, and I hope that you have a great day.